What if I told you that these tiny pockmarks on Mercury hold the secret to understanding billions of years of cosmic history? Welcome back to the channel. Today we're diving deep into one of the most fascinating features of our solar system's smallest planet, Mercury's incredible crater landscape. Now, when you look at Mercury, the first thing that strikes you is how absolutely covered it is in craters. But these aren't just random holes. They're like geological time capsules that tell us story after story about our solar system's violent past. Mercury is essentially a history book written in impact craters, and we're only just beginning to learn how to read it. Let's start with why Mercury has so many craters compared to other planets. The answer lies in its location and its lack of atmosphere. Mercury sits closest to the Sun, making it a prime target for all sorts of space debris that gets pulled in by the Sun's massive gravity. But unlike Earth, which has an atmosphere that burns up most incoming objects, Mercury has virtually no atmosphere to protect it. So every rock, every asteroid, every piece of cosmic debris that comes its way, boom, leaves a permanent mark. And these marks don't get erased because Mercury has no weather, no erosion, no tectonic activity to wipe the slate clean. What's truly mind-blowing is that some of these craters are literally billions of years old. They've been sitting there, unchanged, since the early days of our solar system. That means when you're looking at Mercury's surface, you're essentially looking back in time to when planets were still forming, and the solar system was a much more dangerous, chaotic place. Scientists can actually date these craters by looking at their features. Fresh craters have sharp rims and clear ejecta patterns, while older ones get softened over time by micrometeorite impacts and solar radiation. One of the most famous Mercury craters is the Caloris Basin. It's absolutely massive, about 960 miles across. To put that in perspective, that's wider than the state of Texas. The impact that created Caloris was so powerful that it sent shockwaves through the entire planet, creating weird hilly terrain on the exact opposite side of Mercury. That's called antipodal terrain, and it's like the planet literally rang like a bell from the impact. But here's where it gets really interesting for 2025 and beyond. Right now, there are missions like Colombo that are giving us unprecedented views of Mercury's surface. We're discovering that some craters might contain water ice in their permanently shadowed regions. Yes, water ice on the planet closest to the Sun. How is that possible? Well, because Mercury has almost no axial tilt, some crater floors near the poles never see sunlight. Temperatures there can drop to -300 degrees Fahrenheit, cold enough to preserve ice for billions of years. And these aren't small deposits. We're talking about potentially significant amounts of water ice that could tell us about how water was delivered to the inner solar system. But the craters tell us more than just water. They reveal Mercury's geological history. The density of craters in different areas tells scientists which regions are older. More craters mean older surface. This helps create a geological map of the planet's evolution. We can see evidence of volcanic activity that happened after the heavy bombardment period, smoothing over some older craters with lava flows. The variety of crater types is also fascinating. You've got simple bowl-shaped craters from smaller impacts, complex craters with central peaks from medium-sized impacts, and then the giant multi-ring basins from the real monster collisions. Each type tells us something about the energy of the impact and the properties of Mercury's crust. Recent high-resolution images are revealing features we never knew existed: subtle patterns in crater floors, evidence of landslides on crater walls, and strange magnetic anomalies associated with certain impact sites. Some craters even show evidence of hollows, bright, irregular depressions that might be formed by volatile materials sublimating away when exposed to sunlight. As we head further into 2025, the data pouring in from current missions is revolutionizing our understanding of not just Mercury, but planetary formation in general. Every new crater detail adds another piece to the puzzle of how rocky planets evolve. The pockmarked surface of Mercury is like a cosmic crime scene, and we're the detectives trying to piece together what happened during the solar system's most violent era. What's incredible is that this isn't just ancient history. The cratering process is ongoing. New impacts happen all the time, just at a much slower rate than during the early solar system. So Mercury continues to accumulate new stories on its surface, waiting for future missions to read them. Which Mercury crater fact amazed you the most? Drop your thoughts in the comments and follow for more cosmic discoveries.